Doing well. Um, this is recorded way before I think we're actually going to use it, and that's fine. But at this point, I hope that everyone has their power back and has the internet and are back at home. That was an unexpected. Yeah, we all like a snow day, but we don't like that. So I hope everyone's doing okay. Today we're going to talk about kind of the final component to the property of exponents that we cover in 8th grade and in freshman math. It's kind of what we do with zero and negative exponents. So let's go ahead and talk about it. Before we jump in, though, let's talk about where we kind of ended before we left, and that was with division properties of exponents. So you've already seen that top thing. 5 to the 7th power divided by 5 cubed, we could rewrite as 5 times 5 times 5 times 5 times 5 times 5 times 5 divided by 5 times 5 times 5. That's a lot of 5s, which equals 5 to the 4th. If you remember right then before we left, how that works is these 3 on the bottom cancel out 3 on the top, leaving us with 4 5, hence 5 to the 4th. Same thing over here with the x's. 2 on the bottom, or the 4 on the bottom, cancel out 2 on the top, or sorry, 4 on the top, leaving us with 2, or x squared. So now I want you to think about, what does that look like if we flip it, right? So it really kind of works the same way if you want to look at it from a visual standpoint. So we have 5/3 divided by 5 to the 7th power. Now we could go ahead and expand that and write it down in standard form. I don't know if it's really going to help us. That's the reason we use property of exponents, is to make the math easier. And it is easier this way. This way it's actually mental math. So these 5, in this case, these 5 cancel out, sorry, those 3 5s cancel out 3 on the bottom, leaving us with 4 on the bottom. Hence, we would write that as 1 divided by 5 to the 4th power. Right? So basically, we're just flipping it. But you'll notice that we have that 1 on the top. It's really good of us to remember, key to us to remember that there's always a hidden 1. Like, it's always ones and zeros always find themselves in math in places where, we're like, where'd that come from? Just remember that if I'm not changing this top at all, but I just put a 1 in there, right? 5 times 5 times 5 is 125. 125 times 1 is still 125. So, I don't know. Just keep that in mind. There's always that 1. Same thing happens with the r's over here. We have r squared divided by r to the 5th power. The 2 r's on top cancel out 2 r's on the bottom, leaving us with 3 r's on the bottom. We have that 1 that's kind of hanging out there we can't see, so we have 1 divided by r cubed. So just kind of think about that when we're going over these properties. I think it will make it a little bit easier to understand how they work. One final thing to think about before we jump in, I'm not going to write this out, but what do you think happens with this? Just think about that one real quick. All right, so a couple properties for us to go over here. So the first one is negative exponents. For any non-zero number, a, an integer n, the expression a to the negative nth is the reciprocal of a to the nth. And also, a to the nth is the reciprocal to a to the negative n. So what that essentially means is if I have, let's say I had 5 to the negative 2nd power, okay, remember that a reciprocal is basically just flipping a fraction. So I could write that this way. So that means if that's to the negative, I can rewrite that, right, and do the 1 to the top, flip it, and then just make that positive. That's really what it's saying. So 5 to the negative 2nd power divided by 1 is the same as 1 divided by 5 squared, or 1 divided by 25, right? Conversely, right, let's just say I had 5 squared, conversely, that's 5 squared over 1. Conversely, I could write that, if I wanted to, as 1 over 5 to the negative 2nd power. Now, the reason you do this second example, I can't think of off the top of my head, but it's good to know that you can flip it either way. It makes it easier to manipulate. Now, if you think about that, if you really think about this, if you plug this into a calculator and do 1 and then put 5 to the negative 2nd power in parentheses, you're going to get the right answer, right? It might look confusing there, but remember, this is really a fraction, but we'll get into that in a second. Or a decimal, really. Or really either, depending on how you write it. All right, the easy one to remember is 0 exponents. Anything to the 0 power other than 0 is 1. So any non-zero number, a, with an exponent of 0 is 1. It doesn't matter if it's 6 million 413 to the 0 power, it's going to be 1. Okay, now let's think about that, what I was talking about earlier. Let's go back to that x squared divided by x squared. Okay, so we could write this as x times x over x times x, right? So what we have here is this cancels that out, this cancels that out, so we're left with 1 over 1, which just equals 1. Now let's think about that. 2 minus 2, if we're going back to properties, the division property of exponents, 2 minus 2 would be x to the 0, right? Hence, x to 0 equals 1. A lot of equal signs there. You get the idea. So just keep that in mind. Go back to the x thing, the x squared divided by x squared example. If they're canceling each other out, there's always that 1 there we can't see. All right. So the key here, key takeaway though, is anything to the 0 power other than 0 is simply going to be 1. All right, let's look at this. So we have 4p to the 5th k divided by 3. All that quantity is raised to the 0 power. Okay, let's do a lot of thinking about this. Oh, I'm done thinking. It's 1. It's just simply 1. That's it. Perfect. 1. Awesome. Now, some people are like, oh, are you sure, Mr. Robinson? Well, let's find out. So I'm going to add a hidden right there. So I know 4 to the 0 power is 1. Then 5 times 0 is p to the 0 power, which is also 1. Then I have k to the 0 power, which is also 1, divided by 3 to the 0 power, which is also 1. So I essentially have 1 times 1 times 1 divided by 1, which is 1 divided by 1, which is 1. It's 1. All right, so anything to the 0 power is 1. All right, this next one looks way harder than it actually is, but let's go back up those rules. Remember, if it's to the negative power, all you're doing is switching the location in relations to the fraction bar. So in this case, where we have the y to the negative 4th, all we're going to do is move that to the bottom, and all we're going to do with the z to the negative 3rd is move it to the top. The x squared is going to stay right where it's at. Why is the x squared going to stay right where it's at? Because it's already positive. Okay, another way of looking at this equation before we solve it is just break it down into its component pieces. So this would equal x squared divided by 1 times y to the 4th divided by 1 times 1 divided by z to the negative 3rd power. All right, so anywhere you see a negative exponent, right, there's nothing to simplify because there's only one of each variable. We're just going to switch it to be on the opposite side of the variable. So this is going to stay where it's at. So I'm going to rewrite this. So I have x squared over 1. I'm going to switch this, right? So the reciprocal, right? But change the exponent to positive. And then switch this one over 1, which would equal x squared z cubed. And then finally we have y to the 4th. Okay, so I do realize that, yes, I've been teaching this for, I don't know, 10 years now, and this is definitely material I'm comfortable with. So sometimes I'll glaze over this a little faster than I need to, or I should. We'll be doing a lot more examples in class, and you guys can ask Miss Olson and I as much as you want in terms of these. I kind of actually think they're fun to do, because even though the math itself isn't necessarily entirely complex, it's kind of a fun puzzle to play in your head. The key here is just remember, if you see that negative exponent, try to simplify like you normally would with the division problem, and the next problem will have to do a little bit of that. And then just move it to the proper side of the fraction bar depending on the sign. If whatever you get's positive, great. Leave it. If it's negative, switch it. All right, let's do one more problem. Ooh, and of course I've been doing this this is my 3rd video I filmed today, and this is the first one that bugged out on me. So, why wouldn't it be? Let's go see if I can unbug it. Maybe not, maybe so. All right, usually it will kind of correct itself. There we go. Okay, now, before we even do anything with this one, I really want to encourage everyone to break it down into its pieces. So we have our coefficient, so we have 6 divided by negative 2. Now, there's no exponent rule trick we have to do there. It's just 6 divided by negative 2. That's ultimately going to turn out to be negative 3. Times, we'll do the next one in blue, we have a squared divided by a squared. So I'm hoping you're recognizing right now that's just going to turn into a 1 and go away, right? And then we have b to the negative 6 divided by b to the negative 5th. And then finally we have, sorry, let me make that dot black just to be consistent with how I'm displaying it. Then finally we have c to the 8th power divided by c to the negative 1st power. All right, let's start with this. What do we have? So 6 divided by negative 2 is simply negative 3, right? It might be helpful to make it negative 3 over 1 just because we have other things we have to deal with. All right, so a squared. So remember, the trick with division is subtract. So 2 minus 2 is 0. So this turns into a to the 0 power, right, over 1. Or, well, you're going to find out just 1 here. We're going to add a couple steps that we don't necessarily need here. So negative 6. I'm going to break this out on the side here. Negative 6 minus negative 5. Now, I'm doing this intentionally because a lot of students forget if you're subtracting a negative number, it's actually adding. So I have negative 6 plus 5. I have negative 1. So this is b to the negative 1 over 1. And then I have this next one here to be 8 minus negative 2 is 8 plus, 8 minus negative 1 is 8 plus 1, which would be 9. So that'd be c to the 9th power over 1. Okay, what's staying on top, what's going away, and what's going to the bottom? Okay, well, this is going to simply turn into 1 over 1. This is just going to go away. It's gone. So I have negative 3, right? The c to the 9 is going to stay on the top because it's already positive. And then that b is going to be moved to the bottom. And when I move it to the bottom, I can go ahead and get rid of the exponent of negative 1 and just go with b. So it's negative 3 c to the 9th. Okay, now these problems are complicated. And it's not necessarily intuitive when you look at it the first time. I would encourage you to do more than one, do multiple of these, spend a little bit of time on IXL practicing more than what you're assigned, and be willing to struggle with it a little bit. Look at the problem, see if you can figure it out. Be willing to struggle with it. It's okay not to get it right away. If it takes you a second to figure something out, that's perfectly fine. That's part of learning. I wouldn't expect any of my students to look at this instantly and understand exactly how it works. And if you do, that's great. I mean, sometimes it works out that way, but often it doesn't. So just keep that in mind. All right. Okay. Thanks for watching this. I hope you guys all found it useful, and have an amazing day, night, morning, whatever it might be. Bye.